Namaste and welcome to CADEC Learning Series. In the first video of CADEC Geometry, that is CADEC Miti, we created a part and its drawing. Now we'll create uh, two more parts and we'll create the conveyor assembly and we'll create its drawing also. So I'll start CADEC Miti. In the previous video, we created this part, horizontal channel. Okay. So and we had created this stream also. This stream was the features, sketches, and the entities, that is the modeling strategy of this horizontal channel. So we can create a vertical channel using the sketcher and features also. But CADEC is used mainly for uh, creating models automatically. So we'll see how to use this template and create a modeling strategy of a vertical channel. So I'll create a new worksheet. I'll call this vertical channel 150 by 75 by 600. Let's say the profile is 150 by 75 and 600 is the height. So I don't need the second sketch. So I'll only copy up to the first sketch. I'll specify a different name. I'll call this vertical channel, and I don't need this second feature. I don't need this second sketch also. Uh, Now since the vertical channel sketch, profile sketch should be on top plane, so I'll make that change. We have these many lines here. Uh, since the first sketch was on first plane, Z was 0. Now this sketch is on top plane, so Y will be 0. So I'm copying this Y values into Z values. I'm copying these Y values into these Z values, and the Y values will be 0. Now I can save this and we can generate a uh, channel, but I need to change the values here. So wherever it is 50, I want to make it 75. So wherever it is 50, let us replace it with 75. Wherever it is 45, let us replace it by 69 because the channel thickness is 6 mm. Okay, now only thing is wherever it is 5, we have to change it to 6. So we have made our new modeling strategy. I'll save this and in CADEC I'll open this. I'll create a part from this modeling strategy. So this is top plane and okay, this should be 600. So we have created our uh, vertical channel, which is 150 by 75, 600, thickness is 6 mm. So I will uh, save this. Maybe I can say export as step if we want. Uh, we need to create our third part now, which is a stepped shaft. So this time we'll create a surface model, and we'll use revolve. So first I'll create a uh, sketch. I'll create uh, I'll create a line, and specify the line dimensions as it is from minus 200. Uh, the height will be 15, and 2 plus 200, 15. Okay, so we need to create two more lines. So this is minus 210 to minus 200, sorry, minus 215 to minus 210, and another line here. This 215 to 210. Then we'll create two more lines. This is minus 210 to minus 250 and 10, and 210 to 250, 10. Since we want to revolve, I need to create a center line. So I'll make it on along the x-axis. Okay, so and the plane is front plane. I'll close the sketch. This time I'll use a revolve, and since the profile is open, it should create a surface, and the extent is 360 degrees, and I'll create. So it's asking me for the part name, so I'll specify this as step shaft. Okay, so it has created a step shaft now, which is of 400 mm, and these two are 50 mm each, and this diameter is this this diameter is 20 mm, and this diameter is 30 mm. Okay, so this shaft is also created. I will close this. So we have created our part. Now we want to create our assembly. So for assembly, we'll create a new assembly. Okay, so we'll specify the assembly name. We'll call this assembly as uh, conveyor assembly. I'll save this. Okay, So we need to choose the parts to be added to this assembly. So the first part is horizontal channel. Then we'll also need vertical channel, and we'll need the step shaft. Okay. So we need to add two horizontal channels and four vertical channels, and we'll create add one shaft, and then we'll do the pattern of the shaft by using the command stream. So horizontal channel we need two, vertical channel we need four, and shaft we need one. Okay, so the parent we need to choose. So for all the parent is the same. The parent is the assembly. So here we are creating the mate conditions. The mates can be transformed along XYZ with respect to the parent. Rotate the part uh, about the uh, part axis XYZ, and revolve is the rotation around the assembly XYZ axis at a distance. So currently we are not using the revolve functionality, we use only the translate and rotate. So the first part, since we have drawn it on top plane at origin, we need to move the mm, uh, uh, first horizontal channel by 200 mm, and the second one will move at minus 200, and the first will be there is no rotation. For the second one, it has to be mirror image, mirror model of that. So it should be rotated by 180 degrees about the z axis. Then the vertical channel. The vertical channel, first vertical channel will, okay, and these need to be moved along the y axis also, uh, at, since the vertical channel is 600 mm and the uh, half of the height of horizontal channel is 50 mm, so we'll move it by 650 mm. Okay, the vertical, first vertical channel will move by 200 mm, the second by uh, minus 200 mm. The first will be, there is no rotation. For the second one, the rotation is, now this will be rotated about y axis. So I'll make this y rotation as 180. The next two vertical channels will be at the end, other end. So the z value will be negative 2925. This will be negative 75. Okay, so these will be now 200 along x, then 0 along y, and minus 2925 along z. The second one will be minus 200, 0, minus 2925. Now, first will be there is no rotation. Second is rotated at 180 about at by 180 degrees are about the y-axis. So we have made the changes for mates for vertical channel. Now the mates for the uh, step shaft. So step shaft is uh, moved up by 650 mm, and along Z it will be moved by 50 mm in negative Z direction. So it will be minus 50. Uh, we have created the modeling strategy. I'll create this assembly. So the assembly is created. You can see that the four vertical channels, two horizontal channels, and the first shaft are inserted in the assembly. Now the remaining part is we need to create a pattern of this shaft. So we can do that in the assembly stream. So I'll save this as 3D stream. So now it has created a stream of this assembly. Again, we'll create a new maybe conveyor with shaft pattern. I just copy this, paste it here. So now what we need to do is we'll just give this as a different name, maybe conveyor assembly v2. And now the since the assembly name is changed, I need to change it here also in the parent. Okay, and the only change to be made is we need to have um, uh, the number of shafts. So we had started with minus 50 and gone till minus 2950. So that means the number of shafts was there are total 59 shafts. So we'll just okay, I'll just copy this so many times. And this 50 we need to make minus 100 and so on. Okay, we don't need this. So I will save this. So we have three parts. The first part is added twice, for second part is added four times, and the next part is added so many times, and the mates are updated. I will save this and I'll close this. I'll load the new stream, which is the CMSA. CMSA is assembly stream. I'll choose the second sheet. In assembly, the modeling strategy is components required and the mates to be given. Create this. So it has created a assembly of all these parts and shafts, etc. Uh, we can see the assembly tree also. So the assembly tree has conveyor assembly plus horizontal shaft and so on. We can also see the bill of material of this. So it has two horizontal channels, four vertical channels, and 59 step shafts. Okay, we can create a drawing of this also. So it has created a drawing of this also. So this completes our second video. Thank you.